So hi, everyone, and welcome back to our second interaction with Dr. Claire Parkinson this week, or at least formal interaction. I know the grad students have had another one as well. So for those of you who missed her really great Reberg lecture on Wednesday, I'll just give a brief overview of Dr. Parkinson and then pass it off to Isabella to introduce today's talk and other events. So Dr. Parkinson spent her undergraduate career at Wellesley College in Massachusetts, where she graduated with highest honors in 1970 with a degree in mathematics. She received master's and PhD degrees in geography and climatology from The Ohio State University in 1977. Dr. Parkinson then joined the NASA Goddard Space Flight Center in 1978, and she has remained there ever since. Dr. Parkinson has received an impressive number of honors in her career. Among many other awards, she was the first female recipient of the Goldthwait Polar Medal from Ohio State's Byrd Polar Research Center in 2004. She has received multiple NASA Achievement Medals, including most recently the Distinguished Service Medal, which she was awarded in 2020. So when most of us were just fighting for toilet paper, she was receiving Distinguished Service Medals. Dr. Parkinson is a fellow of the American Meteorological Society, the American Academy of Arts and Sciences, the American Association for the Advancement of Sciences, and the American Geophysical Union. She was elected to the U.S. National Academy of Engineering in 2009, the American Philosophical Society in 2010, and the U.S. National Academy of Sciences in 2016. Isabella?
Yes, thank you, Elizabeth. And I want to, before, I just move on to introduce today's events. Just if you have any question, please, put the question in the chat, and we will, me and Elizabeth, we're just gonna read them at the end of the seminar, and so to Claire, and she's gonna answer them. So you can start during the seminar. So later today, we will have, like at 12:30. So we will have get the chance to speak with Dr. Parkinson about, in a seminar for women in STEM, which is not just for women in STEM, but, everybody is invited. It's just like to have a perspective of what it means to be a woman in STEM. And there's going to be a discussion. So everybody is welcome to ask questions. And, she has been a big, strong supporter of women in science through all her career. In 1993, Claire became, 15 years after her PhD, which is pretty impressive. Claire Parkinson was elected as the project scientist of the NASA Aqua mission, which was launched in 2002, and is part of a very ambitious NASA project, which is the Earth Observing System. Project scientist essentially means that you are the big boss of the mission. You have to make decisions, and you are responsible for a lot of, those, of the things that are ongoing. And Aqua covers the entire Earth with 6 instruments daily to provide a huge amount of data on the ocean, atmosphere, ice, and land. The NASA Earth Observing System completely changed the way, the way we are looking at, using remote sensing to monitor the Earth. And, with the first global maps of radiative fluxes, ocean color, vegetation cover, aerosol, water vapor, and many more. The Aqua mission was designed as a 6-year mission, but it's still working. And Claire is going to give us insight on to what it takes to put together a mission like this, manage it, and the right physical product to study our climate change. So please join me to welcome Claire Parkinson today and thank her very much for making this presentation.
Okay, thank you very much, Isabella and Elizabeth. And I will proceed to share my screen here. So, do you see it now?
Yes.
Okay. Okay. Aqua launched back on May 4th, 2002 at 2:55 a.m. in the morning. It launched out of Vandenberg Air Force Base in California. And almost immediately after launch, very quickly, most of the rocket falls down into the Pacific Ocean, and but the second stage keeps pushing the spacecraft along. So the second stage keeps pushing the spacecraft down south across the Pacific, over Antarctica, and up toward Africa. And while it's up in the vicinity of, there's a tracking station in Kenya, and that's when the second stage drops off and Aqua becomes a real satellite on its own, orbiting the Earth. And that happened 59 minutes, 20 seconds after the launch. 12 and a half minutes later, as it's passing over Northern Europe, the solar array unfurled. This was a big moment because you've got to get that solar array out to get power to the spacecraft. It's at that time, it's at that time that the control of the spacecraft shifted from Vandenberg Air Force Base in California to Goddard's Mission Operations Center at Goddard in Greenbelt, Maryland. So the launch, 2:55 in the morning, the timing of the launch of any of NASA's satellites is always aimed at getting it into the orbit that you want to get the spacecraft into. And in our case, we wanted our spacecraft orbit to be at a height of 705 kilometers above the surface of the Earth. At that height, it takes 98.8 minutes to get once around the Earth. And we also wanted the spacecraft to go north across the equator at 1:30 in the afternoon, which necessarily means it's going south across the equator on the other side of the Earth at 1:30 in the morning. By the time it comes up again to go north across the equator, the Earth has spun about 25 degrees of longitude, and so it's still coming up at 1:30 in the afternoon across the equator. It's just now it's shifted by about 25 degrees of longitude. So that's the orbit, and these are the instruments that are on the spacecraft. We have 6 major instruments. 4 of them are still operating 19 years after launch. As Isabella said, this was a design life of 6 years. So 19 years after launch, we're still going strong. Our 19th anniversary was 3 days ago on Tuesday of this week. And for the instruments, the AIRS instrument, which stands for Atmospheric Infrared Sounder, and that's unique to Aqua. That instrument is still working, and one of the 2 other sounders, the Advanced Microwave Sounding Unit, AMSU, is also working. The other sounder, humidity sounder for Brazil, which was provided by the Brazilians, that one only operated until February of 2003, so that one's no longer working. The MODIS instrument, standing for a Moderate Resolution Imaging Spectroradiometer, is still operating great. There's also a MODIS on the Terra satellite. Terra launched in 1999, December of 1999, so like a year and a half or 2 years and a half before Aqua launch. So those are the 2 MODIS instruments, Aqua and Terra. And the Ceres instrument, we have 2 Ceres instruments. That stands for Clouds in the Earth's Radiant Energy System. Aqua has 2, and Terra also has 2. And before Terra even, there was a Ceres instrument on the Tropical Rainfall Measuring Mission, or TRMM. And now there's Ceres instruments on the SUMI NPP and on NOAA 20. And then the other instrument on Aqua is the AMSR-E instrument, which was an instrument that was provided by Japan, the Japan Aerospace Exploration Agency, abbreviated JAXA. And it got us a great 9-year record until 2011, October of 2011, when the science quality data stopped coming down from the AMSR-E. Fortunately, some data were still available from AMSR-E, and it was enough to provide good calibration with JAXA's follow-on instrument, which is the AMSR-2 instrument. So, but then after getting that calibration data for AMSR-2, the AMSR-E on Aqua was turned off completely in March of 2016. So those are the instruments. And the next set of slides is just going to illustrate for you some of the types of things that we're getting from these instruments. So the series instrument it's only got 3 channels, which is by far the smallest number of channels. But those 3 channels are really aimed very specifically at getting the energy budget. And so those are 3 really important channels. One gets shortwave radiation, one gets total radiation, so you subtract it and you get your long wave radiation, and the other is an atmospheric window radiation that's obtained from the 3rd series instrument. So series gets us the information at the top of the atmosphere, the radiation coming out from the top of the atmosphere, both the reflected radiation from the sun, which would be the shortwave radiation, and also the radiation emitted from the Earth, which would be the long wave radiation. And the series science team uses this information along with the series information from the Terra satellite and connects it with solar radiation from an entirely different satellite, and is able therefore to get the energy imbalance at the top of the atmosphere. And this energy imbalance is really important for the quantifying the imbalance that is leading to the global warming. So now moving down from the top of the atmosphere to down further into the atmosphere, MODIS has both visible and infrared radiation. And this is a picture from MODIS from yesterday. So this is yesterday's picture of the globe from MODIS. And you can see from the visible data how prominent the clouds are. And indeed, cloud studies are a really important set of studies that have been done with the MODIS data. The black strips that you see, the satellite orbit is such that the MODIS instrument scanning doesn't get complete coverage, but there are these strips, and with the next day's coverage, all those black strips are gone. So this illustrates what the scientists using the cloud data from Aqua and Terra MODIS instruments have been able to find out. And this is from a paper by Michael King and his colleagues. And here you see in the solid lines the Aqua data, and in the dotted lines the Terra data. And you see both sets of data for land, which would be the red plots, ocean, the blue ones, and combined land and ocean together, the light blue ones. So first of all, it's very clear that there's more cloud cover over the oceans, which anybody would expect, because the oceans has the water that's what ends up forming the clouds. So an interesting aspect of this is, first of all, you could see the clear difference between over land, the Aqua data show more clouds than the Terra data, and that is simply because of the time of day. Aqua is getting data at about 1:30 in the afternoon. Terra is getting data at about 10:30 in the morning. So it's a time of day issue that's causing the differences. And then the ocean, it's the opposite. You've got Terra getting slightly more than Aqua. But when you combine them, look at how close it is when you combine the land and the ocean. It's really quite comparable, and in both cases, both the Aqua and the Terra data comes out about 65% coverage of clouds at any time. So this is actually a new result obtained from having this MODIS instrument able to look at clouds, because in general, before the satellite data, it was thought that clouds covered roughly half the area at any time. And now the data show that it's more like 67%. So that's often true with the satellite data. You can get refined and much better numbers than what you could guess at before the satellites. And the experts in clouds who use the MODIS data also look at the trends, and this shows the trends in the data. And you can see that for some regions, the trends have been toward more cloud coverage, and for others toward less cloud coverage. So there's certainly not a uniform story here in terms of more clouds or less clouds. It's definitely mixed. A cloud feature that is amongst the most popular to look at would be hurricanes, and in the Pacific called typhoons. And here's a picture from the Answer E in the middle of the night. And I put this up specifically because I wanted to point out that the Answer E, since it's measuring microwave radiation, it can get pictures like this in the middle of the night, whereas a visible instrument would be hindered from getting a great picture of a hurricane in the middle of the night. So, and this also has a tremendous eye of the hurricane too. Here's another illustration from the Answer E, but this time just one channel of information. The 89 gigahertz channel was used, and you can see how with that one channel, you end up seeing the rain bands of the hurricane kind of highlighted. And here shows that with Answer E, you can actually get rainfall rates. And if you look at these two maps, the top is from the Answer E from Aqua, and the bottom is from the Tropical Rainfall Measuring Mission, the TRMM. And if you look at these two, you can see how well the Answer E data is able to match the TRMM data and extend it to higher latitudes, because TRMM, it only goes north and south to at 40 degrees. So it's really good confirmation of both instruments that they match so well, but it's also nice that the Answer E is able to extend the TRMM rainfall measurements to further poleward. Now, with clouds, with hurricanes, you can see clouds, you can see a hurricane, but there are lots of aspects of the atmosphere that you can't see. Like you can't see how much carbon dioxide is in the atmosphere, or ozone, or water vapor, or sulfur dioxide. The AIRS instrument has an amazing number of channels, 2,378 in the infrared, and then it's also got 4 in the visible. But this plot shows the 2,378 infrared channels from AIRS at one particular location, happens to be off of Africa, and one particular time. And I put it up to show you that sort of the regions of the spectrum that the AIRS scientists are able to use in order to collect information about various components of the atmosphere: carbon dioxide, ozone, sulfur dioxide, water vapor, carbon monoxide. And so the AIRS team has used these data, and I'll start with the carbon monoxide data, which is a pollutant in the lower atmosphere. And it comes both from human activities, but also from wildfires. And the picture on the upper left shows carbon monoxide from wildfires from California back in 2018. The plot on the lower right shows the trends of the carbon monoxide data from airs for the Northern Hemisphere, and it also shows the trends from the MOPIT instrument on Terra. MOPIT stands for Measurements of Pollution in the Troposphere. So MOPIT is specifically to measure pollution, and look how well the AIRS data is able to match the MOPIT data for the carbon monoxide. And you can also see the decrease over time, which is a good sign. This is shows some results of restrictions on like motor vehicle carbon monoxide pollution. So it shows that the AIRS team has been able to really do a great job at getting the carbon monoxide data. This shows the carbon monoxide data for February of last year versus the average over the previous years from 2003 all the way up to 2019. The blues mean that February of 2020 was less than the average of those previous years. The reds mean it was more. So the reds in this graphic show regions where there were wildfires back in February of last year. But the blues are really the interesting part here. February of last year, Beijing essentially shut down because of COVID-19. That's why the carbon monoxide is so much less than it had been in any of the previous Februaries. So the AIRS data was very capable at showing the impact, this particular impact of the COVID-19 lockdowns. Now I'm going to turn to greenhouse gases. So this is just a schematic of showing that what a greenhouse gas does. And essentially it lets solar radiation in fairly readily, but it blocks a lot of the terrestrial radiation that would, without the greenhouse gases, have gotten out and gone to outer space. So that's essentially what the greenhouse gas does. Lets the solar radiation in and blocks a portion of the outgoing radiation. AIRS is able to get several greenhouse gases. The most abundant greenhouse gas in the atmosphere is water vapor. And AIRS can get water vapor really well. These two maps show global picture of water vapor in one particular month, and the top one shows the upper atmosphere water vapor, and the bottom one shows the lower atmosphere or troposphere water vapor. The greenhouse gas that gets the most attention is carbon dioxide, and that's the second most abundant greenhouse gas in the atmosphere. And the reason it gets the most attention is because we know humans are increasing the amount of carbon dioxide in the atmosphere, and we know that that's having an impact on temperatures. So this is a plot that was done from ground data from Hawaii. It was started by Charles David Keeling back in 1958 and was continued by him for decades, and then was the continuation then was done by his son afterwards. But this is a plot where immediately in the very first years, he could see the annual cycle. The annual cycle of carbon dioxide is very prominent in terms of in the summertime when there's lots of vegetation that's bringing in carbon dioxide from the atmosphere and using it for photosynthesis. In that period, the carbon dioxide in the atmosphere goes down because it's being taken in by plant life, vegetation. But then in the winter, when there's less vegetation performing photosynthesis, then the carbon dioxide goes up. So you get this annual cycle every year. It goes down in the summer, it goes up in the winter. But you also see that every single year, ever since the beginning of this plot, the values have gotten higher. So you've got those two aspects. Now, the AIRS data, which is plotted in the colors in the background here, the AIRS data also gets both of those. The white plot here is from the Hawaii Keeling curve, the carbon dioxide curve from Hawaii. And you can see now each time it goes up, you're getting more reds, and reds are the highest values of carbon dioxide. But also, in addition to that up and down seasonal cycle, more reds each time the carbon, the white plot goes up, you get more reds. But each time you get more reds than you got the last time. So the AIRS data is getting a global picture of both of those features of the annual cycle, plus the fact that the long-term trend is toward more carbon dioxide. Now, of course, the Keeling curve has the huge advantage that it goes all the way back to the 1950s, but it is a good case of the combination of the value of the satellite data that gets the global picture, and then the 1 point data that goes all the way back to the 1950s. The third most abundant greenhouse gas is methane, and the AIRS data also can get methane. And this is a graphic from a paper by Zhao et al. In 2019. And this is, there's a lot of information on this graph, and it's, the x-axis is time, so it goes from 2003 on the left up to 2016 on the right. And then the y-axis is latitude, so it's the South Polar region at the bottom, the North Polar region at the top. But you can see on this, one thing that really comes out clear is that there's more methane in the northern hemisphere than in the southern. That's quite clear. But another thing that comes out quite clear, no matter which latitude line you go across, it's increasing. The amount of methane is increasing. So every latitude, the amount of methane is increasing, and that comes out so clearly in this nice graphic from the Zhao et al. 2019 paper. Now, part of the reason people are concerned about greenhouse gases is that they do tend to warm the planet. And the AIRS instrument is also able to get a temperature record. And in this plot, it shows from a paper by Joel Susskind and his colleagues from 2019. It shows the AIRS data in red, but it shows 4 data sets from surface in situ data sets. And you can see how well the AIRS data is doing versus the in situ data. And in fact, in the paper, the Susskind et al. Paper, they explain that the regions geographically that the mismatch is the greatest between the in situ data and the AIRS data is actually the regions where there are no in situ measurements. And so that's why they're able to say this quote that I've got on the right portion of this slide. We show in this paper that satellite-based surface temperatures can help to improve surface-based data sets in a way that can be extended back many decades. So again, a great illustration that the AIRS data are being checked with ground truth data and are coming out really looking quite good. Now, so that's the atmosphere, and now I'm going to turn to land. And the Aqua data do show the two major ice sheets on Earth, Antarctica and Greenland, and they come out looking good, but definitely Aqua is not the satellite to use for Antarctic and Greenland studies. The Antarctic and Greenland studies are the studies being done at UCI by people like Isabella Vellicagna and Eric Rigneau and their colleagues take tremendous use of data from gravity data from the GRACE satellite and data from laser and radar altimetry, for instance, from the ICESat-2 satellite. And those data are able, the GRACE data are able to show mass decreases on the Antarctic and Greenland ice sheets, and the altimetry data is able to show height distances, but height changes. But I did want to just show that the Aqua MODIS data do allow you to picture the ice sheets, even though they're not the best data to actually study them. The AMSR data is, or was when it was working, great for sea ice studies. The passive microwave data are tremendous data for sea ice studies, and this shows the record from, this shows the minimum sea ice coverage in September of 2007, which was a record minimum at that time. And then it also shows a plot of the monthly average sea ice extents over the course of the AMSR-E record. And you can clearly see the annual cycle in terms of less ice in the summer than in the winter, but you can also see the decreases over this period from 2002 to 2011. Now, in terms of the oceans, the Aqua MODIS and AMSR-E data both get sea surface temperatures, and this is, if you look at these two plots, the top one being from MODIS, the bottom one from AMSR-E, it really is pretty remarkable how closely they match in the sea surface temperatures when you consider that the MODIS is calculating these on the basis of infrared data. The AMSR is calculating them based on microwave data. So again, the match coming out so nicely certainly does help to confirm that both of these data sets are doing a good job. And this, I just brought this one in just to show you a more recent image, and this is MODIS data from February of this year. So this is just a picture of sea surface temperatures. And this one I bring in because to show that sometimes our data are used in combination with other data sets. So this is an image from Hurricane Katrina. And the image on the left shows clouds from the GOES satellite, sea surface temperatures from AMSR, and land from MODIS. So it was a very popular image at that time of Hurricane Katrina. And on the bottom right, I show a picture of the sea surface temperatures from AMSR-E after the hurricane passes by. And you can see this region where you've got yellow colors. The red colors are higher temperatures. The yellow colors are a little colder temperatures. This is called the cold wake after a hurricane passes. When a hurricane goes through, it stirs up the ocean, brings up some colder water from deeper in the ocean, and you get this so-called cold wake after a hurricane. So that clearly comes out well in the MODIS data. This is chlorophyll concentrations from the MODIS data. And then this shows the MODIS data being used to extend the time series from an earlier satellite called CWIFS. And the Aqua data are frequently being used to either extend a data set from previously, or to match up with a new data set that's got from an instrument that's just recently been launched and hopefully will continue on beyond when Aqua is still operating. This shows vegetation on the land, the greening and browning around the world over the period from 2000 to 2017. It incorporates both Aqua and Terra MODIS data. So that's why it's able to start in 2000, because it has the Terra data as well as the Aqua. Now, the browning gets a lot of attention because that's deforestation, in large part is deforestation. But you can see on this map that there's also a lot of greening around the globe, and that's because there are active programs in many countries to actually reforest rather than deforestation. So there's a lot of tree planting going on, and that's contributing to this greening showing up in the MODIS data set. This just shows that our data are also being used to help validate models, and also help to indicate to modelers where they might need more work. And the two images on the left show the series data from Aqua and then model data on the right. And you can see that this is the two leftmost maps are centered on Antarctica. You can see that in the South Polar region, the models really were not getting the surface radiation well, at least according to the series calculations. But on the right, you can see that the models, and this time it's a combination of 7 models, you can see that the models with results pictured on the 2 rightmost images, short wave on the top, long wave on the bottom, really do match pretty well in the general overall picture with the series results on just to the left of them. So the models are used, the Aqua data are used a lot for model comparisons too. And now I'm turning to show some of the more applications of the data. And the US government uses a lot of Aqua data, and a lot of the US government use it. Now, our closest collaborator would be NOAA, and NOAA uses our data every day because it's using the AIRS data in the weather forecasts that they put out. So that's being used all the time. The Forest Service uses our data when there are major forest fires going on. Department of Defense uses it for like dust storms in regions where the troops are. The Environmental Protection Agency, the EPA, uses it for things like air quality analyses. All of these departments use it. And so I'm going to show you some of the types of pictures that are being used in these practical applications. First off would be fires. Fires come out really well from the MODIS data. And the fires in Oregon on the left, clear indication of where the fires are and of the value that this would be to a Forest Service to know the extent of where the fires are. Similarly, the upper right shows the fires in Southeast Australia that were in the news a whole lot in January of last year. So they come out showing really well on the Aqua data. With the Aqua data and the Terra data from MODIS, you can end up actually counting the number of fires, and of course they have to define how they're going to count them, but they have a systematic way, and their fire counts are plotted graphically here for one particular year. And you can see that even though the fires in the US are, of course, tremendously important to us, you can see that they're kind of minimal compared with the number of fires that some other countries get, especially the tropical regions of Africa. So a number of fires is huge in some areas. Another thing that shows up well and has practical applications would be volcanic ash. So here's volcanic ash. On the left is from the Iceland volcano that erupted back in May of 2010 and received a lot of media coverage because the ash from it was stopping air traffic from to and from Europe. And the Federal Aviation Administration, the FAA, uses the Aqua data to see where the volcanic ash is. And individual pilots also do to decide whether it's safe to take a particular route or not. And then on the right is a volcano from Japan back last summer. This one shows a volcano from the Mount Etna eruption back in 2002. And I put this up to show that on the left, you have the AIRS data in the visible near infrared imagery. But on the right, you've got the difference between just two AIRS channels of information. Just subtract two channels, and you can see how that volcano the volcanic emissions just pop out in just differencing two channels of the Aqua data, of the Aqua AIRS data. So tremendous value of these data sets. This shows dust over the Mediterranean back in 2015. From the MODIS data, you can see how dust shows up really well. Dust also shows up even if it's over land, where it's a little harder to see it, but if you get used to these pictures, it really is clear. And so the upper left is from over Iran, the lower right is from China, just March of this year. And this is what some of these dust storms actually look like from the surface. This picture happens to be taken from the US back during the dust storm period in 1935. But you could see why a satellite can see dust, even though if you think of dust the way we normally would think of it, you'd think, how could a satellite see dust? But once you see a picture like this, it becomes very clear how satellite can see the dust. This is a cyanobacteria bloom in the Baltic Sea. This is from Aqua MODIS data. This kind of imagery from the MODIS data, it can be very attractive artistically, but these blooms are really pollutants that the people in the regions, they are not wanting to see this close up. But Aqua MODIS image can be a beautiful image, but it does signify pollution at the surface. This is an image that shows that the oil spills, this is the one, the Deepwater Horizon oil spill back in April of 2010. You can see how well that oil slick shows up. This was unexpected. When this disaster happened, the Deepwater Horizon explosion, when this happened, the MODIS team members decided, well, let's see if we can see it. And MODIS wasn't designed to see oil slicks, but they thought, well, maybe it's going to be visible. And it turned out it sure was. And since that time, they've seen other oil slicks from the MODIS data as well. Now, on all those practical applications that I just showed, they were mostly MODIS and AIRS, but Ceres, even though it's just got 3 channels and doesn't have the spectacular pictures that that the MODIS and AIRS data and AMSR data sometimes have, it's the series data are actually being used a lot for practical applications from the energy and agricultural communities. This energy information is really of value. The series team started this flash flux project where they put out for anybody these flash flux information values. They started it in 2018. Within the first year and a half, there were 35 million requests for this series data. So a really huge practical value from the series data as well as from the other instruments. And now I'm going to turn to just a bit on the fact that the Aqua mission is certainly involved in more than just the science and just the data. It's also got a public engagement. And there's lots of Aqua imagery put on things like the NASA Hyperwall, the dynamic planet. Many talks are given to school children as well as the general public. Lots of involvement with colleges and universities, and also with citizen science. The picture on the upper right in particular, I like this. This was on the cover of the Bulletin of the American Meteorological Society, and it shows a series effort. It was started by series to have kids observe the clouds. It's now gone into the GLOBE program, so it's now called Globe Clouds, but it used to be called the Series School Program, standing for Students Cloud Observations Online. And so they would have kids go out and observe the clouds at the exact time that the satellite's going overhead. And, you know, the kids would get the information. And one cool thing that I really liked on this, that the woman who led this program, Lynn Chambers, I was talking with her at one point, and she described an instance when it was kind of bad weather out, and the teacher of these kids said, "Oh, you don't have to go out today." And one of the little kids said, "You have to let us go out. NASA is depending on us." And that statement just sort of epitomizes to me what citizen science is supposed to be. You know, people who are really taking ownership of the measurements that they're making in the citizen science projects. So to me, that was really a plus. There are thousands of locations around the world which are contributing to this cloud data and which get the satellite overpass times from Aqua, from Terra, and from other satellites. This shows a timeline of the Aqua fuel levels. We started out with 220 kilograms of fuel. When we ascended, a lot of fuel was used up, and each time we do what's called an inclination adjust maneuver, which helps keep the satellite up in the orbit that we want it to be in. Each time we do that, it takes some more fuel. So by now, after 19 years, we're down below, well below 40. We're down below 30 kilograms of fuel. So the fuel's not going to last forever. We know the mission is going to end, if not by some disaster of the satellite failing or the instruments failing. It's going to have to end by running out of fuel, if nothing else. So the predictions for Aqua going forward, there's still a lot of uncertainties about this, but it looks like we can continue in the orbit that we're in, the one at 705 kilometers, crossing the equator, going north at 1:30 in the afternoon, going south at 1:30 in the morning, that we can continue in that orbit, which Aqua was the first satellite in that orbit, but several other satellites followed it. and so it's now called the A train. So we could continue in this A train orbit at least until 2022, at least until next year. Due to fuel limitations, we might end up descending from the A train next year. This is being examined now. All the calculations are being done with new data. So we're not sure that we're going to have to descend in early 2022, but that's still sort of the timeline that's expected right now. After we descend, we'll be a little lower than the A train, maybe about 4 kilometers lower, and we'll still be able to collect data, and good data, and there'll be science applications, and we could conceivably last until September of 2025. And new calculations as of just this week suggest that there's even a conceivable possibility of lasting a year longer than that. So it depends on lots of different things, but among them is budget and the in-guide budget, which means that budget that NASA headquarters has given us to try to work toward. In-guide budget would have us finishing in 2024. We've asked for an over-guide budget. We're going through annual budget exercises right now, and if we're accorded the over-guide budget, then we could go into 2025 and perhaps 2026. This is what happens when we shift out of keeping this, using the inclination adjust maneuvers to keep a very narrow time frame. So our mean local time, meaning when we're crossing the equator, has been at about 1:30 in the afternoon. So on this plot, it's 13:30. Well, it's actually 13:35. So it's about 1:35 in the afternoon. And we've kept within the boundaries of the red boundaries that kind of like our prime mission boundaries, and we've kept well within those boundaries all along. Once we no longer do these control with these maneuvers, the mean local time is going to drift, and it's going to drift to later and later and later. And the plot on the right shows the drift in the mean local time. So the status of the spacecraft is that the overall Aqua bus is excellent. The solar array is doing a great job. It's got 132 strings of solar cells on it, and 110 of them are still operating really well. The solar array, the estimate is that it could probably last really well until early 2028 if we were to stay in the A train orbit. The battery is doing a great job. It could potentially last 150,000 Earth orbits, which would bring it up to mid 2030. So the battery is not a limiting factor at all. Aqua has completed 100,000 orbits. So it's done 100,000 orbits as of February 20th of this year. So we're over 100,000 orbits of the Earth now. So this, I've listed some of the critical responsibilities of the mission operations team. They operate the spacecraft. They download the data from the instruments. They perform these downloads every orbit. They ensure that everything is working. They keep key users informed of what's not working. They get the data down fast enough for the weather forecasting users to use it. They work closely with international and national partners to manage this A train of satellites. They maneuver the spacecraft whenever space debris is looking like it might cause a problem. And they implement requests that come from the science teams. And when there's an anomaly, they fix it. And there was a major anomaly last summer, which was amazing how the whole sequence. Last summer, August 16th, all of the data coming down from the solid state recorder, which is what sends the data down every orbit. So it's the mass of the data that we get from the spacecraft. It was all corrupted. And this happened, like, it was roughly 9:30 in the morning. It was a Sunday. Well, they had that information to me within an hour, and they had that information out to a lot of people within an hour. So they are right on top of this. And then we had meetings that very afternoon, Sunday afternoon of August 16th. And then we had meetings every day, practically every day for the next couple of weeks. And during this period, the mission operations people, I mean, they checked every single thing to figure out how could this be happening? What could be the problem? And they were able to establish, first of all, that it wasn't the Earth observing instruments. Second, that it actually wasn't the solid state recorder. And they were able to figure out that it was a unit called the formatter multiplexer unit. That's the unit that takes the data from the Earth observing instruments to the solid state recorder. So they were able to figure this out and then develop various possibilities of how to fix the problem. And the easiest fix was going to be to reinitialize the FMU firmware. It would be sort of like us when our computer has some problem happening and simply reboot the computer. Well, fortunately, that easiest of all solutions did end up fixing the problem. So this was fantastic. So it got fixed on September 2nd, and all the data started coming out in great shape after that. So mission operations also does, planning for different funding scenarios. So they are critically important. So now, what about me? What does a project scientist do? Well, I'm kind of the key interface between the science teams and project management before launch. So project management was the group that got the instruments built and got the spacecraft built. And then mission operations, that's the group after launch that keeps the satellite operating, and NASA headquarters. So I'm interfacing with all those. And of course, outreach to the general public, presentations, written products like the Aqua brochure, lots of replies to email messages. And then I deal with like project management on the issues of payload issues. I deal with orbit issues after launch with mission operations, that although mission operations is the key there. I help coordinate decisions on things like whether to have a deep space calibration maneuver, which we're about to have for the first time this year. Before launch, the AIRS team did not want a deep space calibration maneuver because they felt it was too dangerous for the AIRS instrument. A deep space calibration maneuver means you flip the spacecraft over and you get a view of deep space in order to get calibration information. So, but now the AIRS team does want a deep space calibration maneuver because now the mission is close to its end, and so now the risk of damage to a very long mission is gone because the mission's not that much longer from this point on. So now they see the benefit of this deep space maneuver. The other teams, AMSR-E, AIRS, AMSR-E, MODIS, and Ceres, they had wanted a deep space calibration maneuver all along. NASA headquarters had decided to go with the AIRS team on that one because they were afraid of the risks also. but now everybody's in agreement to do one. So I coordinate with the teams on that, and then I coordinate with the project scientists from Aura and Terra on various things that the different satellites have to deal with. We've got annual budget preparations that have to be done, annual congressional statements that have to be made, and then two major types of things. Every other year from 2007 to 2017, and now wonderfully they've changed it to every 3 years now, have to put in what's called a senior review proposal. This is a huge proposal. This is a huge effort in the years that it takes place. And then this year we had a Phase F plan. Phase F is the end of a mission. So we had to write up a Phase F plan. So these are the covers of those the last senior review, which was from last year, and the Phase F plan, which is this year. The senior review was like 280 pages. So, I mean, it is a major proposal that has to be put together. The Phase F plan is much easier. It was still a lot of work, but much easier than the senior review. It's 34 pages. So you can just tell by the page count that it would be a whole lot easier. So final slide to conclude. We've been in orbit for 19 years. We can continue to collect very valuable data from all four of the, in fact, it's all four of the US instruments. The two instruments that failed were both foreign instruments, but the AMSR-E, the one from JAXA, Japan, was tremendously successful. I mean, they lasted way longer than their design life, so it was tremendously successful. But the four US instruments are all still working. Thousands of people directly use the Aqua data. Millions are benefiting from it, from things like the weather forecasting and the other aspects of it. We likely will be exiting the A train next year, but it might stay in the A train a little longer. After we exit, we can still take good data, and depending on funding and other aspects, we could continue to take data for another few years. And once the data are no longer valuable for whatever reason, the spacecraft will be passivated, and that will be the end of the mission. So with that, I conclude.
Thank you, Claire. This was awesome. I think that, you know, I love the fact that you point out, you know, you talk about the science, you talk about what are the challenges from the technical point of view, all the work that goes into. It was literally, you know, you told us about, you know, you get information hour after and you are on a phone call to decide what to do with the mission. And, and that's something that we all should be aware of. So you know, we're gonna have a few questions. We have an event at 12:30, so we may not have time for all of them, but we collect them and we're gonna share the chat with
okay, that'd be great.
And but you know, Elizabeth, do you want to start with the first question in the chat and then I go with the next one?
Sure. So Eric says, fantastic presentation about the power of satellite remote sensing for Earth science. Question. As we discussed in CESAS, Aqua is about to end with no replacement for EOS in sight. How concerned are you about this? What will be the impact on Earth science observations? What instruments on Aqua will be continued on a new platform and which are in jeopardy? How about MODIS?
Okay, MODIS, the follow-on to MODIS is the VIRS instrument, V-I-R-S, VIRS instrument. And the VIRS instrument is getting much of what MODIS gets. So it's not getting everything, but it's getting a lot of it, and a lot more than the Modus team had been worried about before the VIIRS got launched. They were very pleased with how much the VIIRS instrument is able to follow on with the Modus. So so Modus is being followed on by VIIRS. The AMSR E is already being followed on by AMSR 2. And again, that is the AMSR E was the Japanese instrument from JAXA. And AMSR 2 is the follow-on, and it's on a Japanese satellite. And so that's carrying on. Then the series instrument is on NOAA 20 right now and on SUMI NPP. So the series instrument, the series team had a lot of series instruments and is able to put them on multiple satellites. So the series, time series is being continued with those instruments, with series instruments on other satellites. Then the AMSU and the HSB, so the two microwave sounders, they actually are on NOAA satellites as AMSU A and AMSU B. So they've got slightly different terminology, but it's the same AMSU, AMSU A and B. And so they are on NOAA satellites that should be continuing. And the airs, there is a follow-on to the airs, and trying to remember exactly what the name is, but rather than guessing, the airs there is a follow-on. It doesn't have anywhere near as many channels as the airs, but you know, sometimes just like with computers, you can make things smaller, and they, you know, with time. And so with the AIRS instrument, it's amazing number of 2,378 infrared channels and 4 visible ones. Because of the information obtained from AIRS, they were able to sort of figure out what were the most critical channels. And so they have follow-on instruments. The AIRS team is certainly working toward more follow-on instruments also. And that the AIRS team is centered at JPL. The Modus team is centered at Goddard. The series team is centered at Langley Research Center in Virginia. And the AMSR E American team was centered at Marshall Space Flight Center in Alabama. And there's also an AMSR E Japanese team too. So the Aqua mission does have, you know, a lot of NASA centers heavily involved.
I'm gonna mute myself. Thank you, Claire. And we have a lot of you know, grad and undergrad also, you know, participating. And so someone sent me question on my, you know, privately, so I'm gonna read them. And I want to say there is no such a thing as a not good question. Every question is good in this, and so please feel free to ask whatever. And again, we're gonna collect.
Yeah, for sure.
And so the question is that, can AMSR E, you know, given that AMSR E can detect hurricane, can this be used to alert citizen, you know, in area, you know, or develop a way to alert citizen in area where, you know, they're critical area?
Great question, and definitely yes. In fact, that particular picture that I showed from the AMSR-E of the typhoon back in 2002. That particular picture was tremendous from the AMSR-E in particular because it was showing a typhoon that was about to strike China and Japan. And the AMSR-E, when it first got turned on earlier in 2002, so when it first got turned on, the data, there was a problem with the data. It only took a couple of days for the Japanese engineers to figure out what was wrong, and they were able to send information to Goddard mission operations as to what instructions needed to be sent out up to the spacecraft to fix this problem. So, but in the meantime, the Japanese newspapers had it all over the newspapers that this AMSR-E instrument was no good and was giving bad data. So that was kind of too bad, because then the AMSR-E was giving great data, and it was kind of amazing how, you know, you can send a signal up to the spacecraft and get the whole thing solved. I mean, it's just amazing what can be done these days. But so when that image came of that typhoon about to strike Asia, I mean, this was huge success for the Japanese to see, wow, their instrument really is working and is providing important forewarning of a hurricane that's just about to strike. So definitely the data are usable for forewarning of hurricane or typhoons, you know. Yes, so the answer is yes.
Elizabeth, do you want to read the next? You have a question.
Why don't you read the other question that you have from the grad student?
I have another question from a student. So student asked me, okay, let me just like, I'm sorry, I have to find it. I have to find them back in my chat because I cannot have the chat. So we have like, it's like, will MODIS be able to identify various species of algae or bacteria bloom in the ocean or large lakes?
The MODIS can definitely identify blooms in lakes, large lakes, and in the ocean. How specifically they can identify which species it is, I'm not sure, but they can definitely, I mean, they can definitely say it's an algae bloom, but if there are multiple species of algae, I'm not sure if they can identify specific species, but they can definitely identify algae blooms and other blooms in the MODIS data.
Thank you. Maybe have time for one more, and then we'll give you a break before the next. So I just wanted to remind everyone, we're going to switch channels over to the Women in STEM seminar at 12:30. So let's see, we'll go, that was a repeat question. So have companies like SpaceX made it easier for satellite proposals to get funded, or do budgets decrease since it can be viewed as a way to cut costs?
I have not seen any impact on the funding because of SpaceX. So in terms of my work, SpaceX has not had an impact. I don't know about other people, but in terms of, it's certainly not had an impact on either my sea ice work or like Aqua funding. So SpaceX does work very closely with NASA on its programs. And so it is definitely, you know, it's definitely a government business collaboration that is certainly producing some powerful results, but in terms of impact on the science funding, I am not aware of it.
Thank you, Claire. I think we're going to wrap out. Thank you so much for this amazing presentation.